Welcome to Study Loop.
Okay, so before we answer this question, we should first solve for the spring constant, which will pop up later. We know the period of a pendulum is 2 pi times m over k. We know m, we know t, so t is 4.2, m is 5 kilograms, which gives us a k of 11.17 newtons per meter. And the other thing we could figure out is that the angular frequency of this pendulum is going to be 2 pi over t, which just equals 1.5 rads per second. Okay. So the speed at any given position is, so the speed is omega x. In this case, x is the full amplitude, so it's omega a, which equals 0.15 meters per second. The acceleration is given by negative omega squared x. So this is negative 1.5 squared times 0.05, which is negative 0.1125 meters per second squared. C is a bit tricky, so what we need to do is project our linear periodic motion onto a circle of radius a for amplitude. And the motion here is going to go between a over 2 and negative a over 2. So the half amplitudes, because it says it goes between 0.05 and negative 0.05, and the full amplitude is 0.1. We want to figure out what this angle theta is. Well, if we take the half triangle here, where this angle is theta over 2, we know that this, the radius is a of the circle, and the height here is going to be a over 2. This gives us an angle here of 30 degrees, which implies that theta is 60 degrees. And then we know that t is going to equal theta over 2 pi, so it's just the fraction of the circle times the full period, which is 0.7 seconds. And I'm going to do part D on a new page. Okay, if the spring will shorten by a length x, so this is kx, this is the force due to the spring, and this is the mass, this is the force due to a mass on the spring. So if we remove this mass, it'll shorten by this length x. We can rearrange it for x, so x equals mg over k, and we have all of these quantities. This is 5 times 9.8 over 11.17, which just equals 4.3 meters.